In this Electronics and More video, I'm going to show you how you can take a wall-mounted microwave oven's ventilation unit, like you see right over here, and convert it into a three-phase crank generator. Let's get started. Right here is the motor once it's been removed from that ventilation unit. This one here is a 120 volt motor, and it has 16 poles. Now when I say it has 16 poles, let me point out exactly what that is. Now if you look right between the squirrel cage rotor, which is this part in the center that rotates, and these pieces of plastic, you're going to see these sections that hang down. One there, one there, one there. Each one of those is a pole. What I'm going to be doing is taking this 16-pole single-phase motor and making it into a three-phase motor. And it is fairly simple to do. I'll show you in a minute, but first let me explain how to remove the old windings when you disassemble the ventilation unit. Right over here, you're going to take a hacksaw, and where the windings stick out, right here, you're going to cut one side off. Once you cut the side off, you'll be able to push the winding all the way through the core and pull them out the back side. Be careful not to damage any of these keepers right here. Let me pull one out and show you. Because once you install the new windings, you're going to be putting those keepers back into position. This unit is only around 1 3/8 inches thick by around 3 1/4 to 3.5 inches in diameter. This is called a squirrel cage rotor. All it is aluminum combined with strips of steel inside. They're either poured that way in a mold or they're laminated. By removing the 3 Phillips screws, there's one here, one on top, and one around the side, it'll make it much easier for you when you go to remove those windings. Underneath this section here is one bearing, and on the opposite side you have another bearing. Push it like that. Now let me explain exactly how this is going to be done. Now if you look at the top of this page right here, each one of these squares is one pole inside that motor. We have 16 boxes. What I decided to do was connect 2 of those poles together to make them one pole. So if you take a look at the motor, I'm going to be wrapping the wire between here and here. This way this pole and that pole are within that turn. It makes no difference how you start off. You can go clockwise and then go on to the next set and go clockwise again, onto this set clockwise, or you can start off counterclockwise as is shown in this image. Now this is the first phase. I only showed you the first one because once I put the next one in, it's going to make this very cluttered and hard to see. So what I'm going to do now is draw in exactly where the second phase is going to be. It's going to be wound in the exact same direction as all of these. So if this is clockwise or counterclockwise, make sure the next phase is also wound the exact same direction. Okay, I drew in the second phase, phase B. You can see the beginning of phase A with the 2 north is tied together with phase B. This is going to be counterclockwise around the north and the south. Same number of turns as used for the 2 norths. And you're going to go, after it's done going counterclockwise, over to the next set of north and south. Go between the 2 south, between the 2 north, wrap it around, and go all the way down the line. Now for the last phase, we're going to come off and we're going to wrap around the 2 souths. We're going to go counterclockwise, 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 and counterclockwise, and leave you with A, B, and C, and the beginning of all 3 phases tied together. Let me draw that in and come back. Okay, now I have phase C in, or the third phase. Ties in at the same point in the beginning, goes up to the 2 souths, counterclockwise, same number of turns, and onto each of the souths. And then it comes out here, phase A, B, and C. Now you know why I drew this a little at a time so you can see each one of the phases, because if you looked at it like this, more than likely you would say, wow, what a mess, and you would not understand it. So now you should have a good understanding of how I'm going to be winding this motor. Now if I wanted, I could have made this a single phase. I could have made this magnet north, that one south, north, south, north, south, all the way down the line, and just used one group of windings. I could have went clockwise around the north, and then counterclockwise around the south, clockwise around the north, and then counterclockwise around the south. Or I could have done it the exact opposite. Like I said earlier, it makes no difference if you start off winding it counterclockwise or clockwise. The primary difference between using single phase and three phase is the power output. And I'm going to explain right now by taking a look right down here. Over here you have an AC sine wave, and this line is 0 voltage. Everything below this line is negative voltage. Everything above that line is positive voltage. So for a single phase output, if this was north, south, north, south, north, south, all the way down the line, you would end up with something that looks just like this. The only problem is, you notice the power is increasing till it gets to the positive peak, and then it's starting to decrease to 0 volts, and then it goes to the negative peak. Between this peak and that peak, there is nothing going on in the way of creating power. Between this peak here, the lower one, and that one there, you have the same thing. There's nothing going on. With a three-phase setup, which is this right here, you're going to have each one of those windings. This is the first one, goes all the way through, and then there's going to be the next one, which is a little off from the first phase. That goes up. And then you have the last phase right here. And as you can see now, instead of this huge space between this peak and that peak, it's been filled in by these extra two peaks. You're going to be getting power now in an area where you were not getting power earlier. And the same goes for the bottom of the sine wave. You would only have this one here and that one there. Now you have two more. The winding configuration is known as Y or star. In the center is where the three windings are tied together, which is right there. And then you have each winding going out. Each one of these windings goes into these diodes. In my case, it's going to be 1N5822s. Those are Schottky rectifier diodes. You definitely want to use that type of a diode. It has a good voltage rating. I think it's around 40 volts, up to 3 amps. And using this particular type of a diode will result in lower losses. You can see the output of A goes between two of the diodes. The output of B goes to the next set of diodes, and C to the last set. All the cathodes are tied together to the positive output, and then you have all of the anodes connected together, and that's the negative output. Across the output you place a 35 volt, 2200 microfarad or even higher. This way you can smooth out any ripples in that DC power supply. Once you have that output, you can connect that to a voltage converter. Let me show you some of the supplies we'll be using. Now to wind this, I'm going to be using 20 gauge enamel copper wire right here. There's approximately 80 feet on that 1/4 pound spool. And once I get mine working, what I'm going to do is tell you exactly how many turns I used, so when you make your own, there's not going to be any guessing as to how many turns. In order to wind this up and make it easier, I made a jig that's going to allow me to make my windings so they fit very neatly between this set of poles right here and the other set here, because the winding is going to go between here and there. This is what the jig looks like. It's made up of 4 small finishing nails. Make sure it's nice and straight. Cut off the head so at the very end you'll be able to slide the coil of wire up and off the nails. Before you slide it up and off, you may have to take some thread, tie a knot on both sides. This way it stays together when you remove it. Once the first one is wound, you're going to leave a little section of wire going out before you start winding on the next section. Leave another section of wire, a few inches long, to make it to the next section where it's going to go, and then you're going to wind again. In my case, because I'm doubling up the poles and there's 16 of them, I'll be using 3 sets of 4, so I'll be making 12 of these windings. Just make sure you have the proper spacing on the nails from left and right, top to bottom. Now, in order for me to glue magnets onto this rotor, you can see the space is very, very limited between the rotor and each one of these poles. It's maybe a 1/16 of an inch. I'm going to be taking this to a machine shop and have 5/16 of an inch removed from the diameter of this rotor. So 5/32 will be gone on this side and 5/32 on the opposite side. The magnet thickness is around 3 millimeters or 1/8 of an inch. It's very important that the magnet that you choose is very close to the width of the poles. You're looking at the core or the stator with the windings removed. It's a better look at it now. You can see each one of the poles. And over here I'm working on one of the windings. Once I get this put together, I'm going to tie a little bit of string. I'll be using this nylon thread just to secure this end and that end so it stays together when I go to insert it into the stator. Let me do it and I'll be right back. The 3 phases that are going to be inserted into the stator are now complete. This is what the stator looks like once all 3 phases have been wound. I started over here. This is the start of all 3 phases soldered together. Goes all the way around and each one ends right over here. I have a nylon tie on each one of these windings to keep it nice and tight, nice and neat. And you can see the inside here, how nice with the keepers. And this is what it looks like on that side. Keep in mind the output, even though it is 3-phase, it's not going to be a perfect waveform like I showed you earlier in the diagram because of the way the coils are laid out with the number of poles that are here, but it will still work as a 3-phase generator. Now, originally I was going to take the rotor off the shaft right here, slide it off of this shaft, and you can see I drilled 8 spots where magnets would go all the way around right in the center, and I was hoping to put a large flat neodymium magnet in each spot, but the problem is in order to make it large enough they would end up either touching each other or being very close to touching each other, and I would have the problem of the laminations in the rotor starting to chip away, so it would have become a big mess. So I removed this part, the rotor, from the shaft. Here's the shaft. And the way that I did that is I slid a 3/4 inch galvanized pipe over the shaft and I tapped down until this slid off the shaft. It's only on there with pressure, it's pressed on, so you have to tap until it keeps moving all the way down and then it pops off the end. Over here is the 608Z bearings. There was 2 of those. One was faulty, so I'm going to be swapping that out, and it's very easy. You can take a socket, make sure it's fit to the diameter of the inside of the bearing, and then you can use it to put the bearing into the correct position. You can also use a bearing puller to remove it. This rotor is 1 3/4 inches in diameter, so what I did is I ordered another piece of aluminum. It was inexpensive, and it's going to be 1.5 inches in diameter, which is a little smaller than this one, 1/4 of an inch, and the reason for that is to allow for the thickness of 2 magnets. The thickness of the other one is going to be 1 inch, which is the center part here between the bottom band and the top band. I'm going to take the piece that's new and I'm going to slide it over the rod, and I'm going to do that by putting this upright and put the 1/2 inch or 3/4 inch galvanized pipe over the end and tap until it slides all the way down. I marked the location everywhere where I'm going to be putting magnets. So instead of putting 1 large magnet, I'm going to be taking these 1/2 inch neodymium magnets. I'm going to be using 2 of them side by side. It's going to give me more area within that stator right over here. It's going to take up more space from top to bottom. So I'll drill a hole just enough to make the area where it's round become flat, so I can epoxy 2 magnets here of the same pole, so it'll be north-north, south-south, north-north, and I'm going to go all the way around. Now that that's drilled to the proper diameter, what I'm going to do is put epoxy inside this opening, push the magnet down until it seats nice and flat, and I'm going to let it set. I'm going to do that all the way around this rotor. This is what it looks like once the holes have been completed. Now I'm going to put epoxy in each one of the holes to bond the neodymium magnet in position. Once that's done, I'll come back and show you what it looks like. And this is what it looks like with all the magnets epoxied into position. North-north, south-south, north-north, all the way around. Okay, this is what it looks like with the rotor back in position inside the stator. Here is each one of the phases, 1, 2, 3, and it's going right into the diodes like I showed you in the image earlier. You have 2 together there, 2 in the center, 2 on the end. Each phase goes in, and then it goes into the filter cap, in this case, which is a 25 volt, 2200 microfarad. And over here I'll have my output. Let me connect this up to my digital multimeter, spin this by hand, and take a look at the output. Okay, you're looking at the voltage of this capacitor right now. We're on DC volts. Let me rotate this by hand and see what the voltage goes up to. Now I'm hardly turning it that fast. And I'm already over 5 volts. This will probably put out around 7.5, 8 volts. And the current is well over 3 amps. So let me just do a short circuit reading right now. Okay, now it's going to be a little harder to turn because it is shorted out. Alright, so let me just put this on here. It'll be easier for me. And remember, this is going to show just a short circuit current. That's a lot of current, 4.5 amps. When this was tested using a 5 volt load, I was able to supply 3 amps at right around 5 volts. So this will be perfect for my project on my bike. I'm going to be mounting this underneath my seat. There's going to be a small pulley on one side, and it's going to be tied into the back wheel. So as I'm riding my bike, even if the pedals are not moving, I'm going to have a power output that I can use to charge my cell phone using a USB jack, and I'm also going to have power supplied to a headlight and tail light. Now if I did make the spacing a little closer on these magnets by adding a 12 millimeter by 1 millimeter thick neodymium on top of these to get that gap a little closer, then the voltage output is going to be higher, as well as that current. That 4.5 amps could be up to 6 amps or possibly more if I made that gap closer. If you desire a higher voltage output, then you can use more turns of wire or use a smaller gauge of wire. Instead of 20, you may want to go to 22 gauge and put a lot more turns of 22 gauge on each one of these windings. Now what I want to do is show you each one of these phases. We're going to check from this point right over here where the star is all tied together. So we're going to put the oscilloscope from this point to each one of these legs or each one of those phases, and I'm going to spin this and show you the sinusoidal waveform coming off of this generator. Okay, let's take a look at the next phase. This is phase number 2. take a look at the top one. Now, if this scope had 3 channels to input, you'd be able to see that the first phase starts at the 0 line and it goes up and it comes back down. The second phase would start a little further in, and then the third phase would follow. You would see that it would look very similar. It would not be perfect like the one I showed you on the piece of paper, but you would get the idea that it's more or less 3-phase compared to single phase, which only looks like this. I hope you enjoyed this video. If you did, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlist as well. Thank you very much for watching.